All right, let's talk about a math problem that is so simple a kid can get it. But for almost 300 years, it stumped the absolute greatest minds in the field. And our story starts in a place you would never, ever expect. I want you to picture this. It's 1954 in Xiamen, China. Air raid sirens are wailing. Bombs are literally exploding nearby. And inside a bomb shelter, while everyone else is terrified, a 21-year-old named Chen Jingrun is just calm. He's completely lost in a math book. So that's the real question, isn't it? What kind of problem is so mesmerizing, so all-consuming, that you can just tune out the world exploding around you? Well, the answer has to do with the absolute bedrock of mathematics. To get what Chen was so obsessed with, we've got to talk about prime numbers. You probably remember these. They're the numbers that can only be divided by themselves and 1. They're kind of like the atoms of the number world. And this is it. This is the problem. It's called the strong Goldbach conjecture. And it's so simple. It just says, pick any even number bigger than 2, and you can always find 2 prime numbers that add up to it. That's it. That's the whole thing. I mean, let's just try it. 6, that's 3 plus 3, both prime. 10, easy, 5 plus 5. Or, hey, 7 plus 3 works too. How about something bigger like 42? Yep, that's 37 plus 5. Go ahead, try it with any even number you can think of. It just works every single time. And you know, what's really wild is the intuition here. If you were to visualize all the prime pairs, you get this shape that looks kind of like a pyramid. And the crazy thing is, as you look at bigger and bigger even numbers, you don't find fewer ways to make them with primes. You actually find more ways. It feels like it just has to be true. And this isn't some niche, obscure puzzle. It has a serious pedigree. It all started with a letter between Christian Goldbach and the legend himself, Leonhard Euler, way back in 1742. Euler tweaked the idea, and by 1900, the great David Hilbert put it on his famous list of the most critical challenges for the next century of math. And this quote right here from Euler gets to the very heart of the frustration. One of the greatest mathematical minds in history was totally convinced it was true. He just couldn't prove it. And that feeling, that absolute certainty without a proof, has haunted mathematicians ever since. So Euler actually broke the problem down into 2 versions. There's the weak conjecture, that's about odd numbers and adding 3 primes. And then there's the strong one we've been talking about, with even numbers and 2 primes. And here's the key. If you can somehow prove the strong one, you automatically prove the weak one for free. For a really long time, nobody made much progress. But then, in the 20th century, mathematicians came up with this brilliant, powerful tool called the circle method to attack the weak conjecture. You can think of it like a giant counting machine designed specifically to figure out how many ways any given odd number could be made from 3 primes. And guess what? It worked. It took decades, but in 2013, a mathematician named Harald Helfgott finally used it to prove the weak conjecture was true. He proved it for all numbers above a certain point, then used computers to check every number below that point, all the way up to 10 to the power of 27. A massive, massive achievement. But, and this is the killer twist, that incredible circle method, the one that took a century to perfect, it's completely useless for the strong conjecture. The math just falls apart. The really hard problem, Chen's problem, was still out there, and it was going to need a whole new idea. Which brings us back to Chen. Why was he so stuck on this specific problem? Well, for him, it all started in high school. His teacher said this to the class, framing Goldbach's conjecture as the ultimate prize, the pearl in the queen's crown. The whole class just laughed. I mean, the idea that one of them could solve it, it was ridiculous. To everyone but Chen. Chen's quest for that pearl led him straight into a nightmare. During China's Cultural Revolution, intellectuals were seen as enemies. He was humiliated, forced into backbreaking labor, and beaten so badly he'd pass out. He ended up living in a tiny converted boiler room with no light and no heat, totally cut off from everything. But he did not stop. In that freezing boiler room, working by the faint light of a kerosene lamp, he kept going. And in 1966, he did it. He had a massive breakthrough. Using a totally different approach, he proved something incredible, the closest anyone has ever gotten to the final answer. He showed that every large even number is the sum of a prime and another number that's almost a prime.
His proof was so complex, so unbelievably advanced, that another mathematician described reading it like this. It wasn't just a smart idea. It was a climb into the most challenging, most remote territory in all of number theory.
Finally, as the political situation started to change, a colleague convinced a terrified Chen to publish his work. He did, in 1973, and the result was just astonishing. The very same government that had tried to crush him suddenly turned around and declared him a national hero. His story became a legend of pure perseverance. But even Chen couldn't quite get the final proof. So you have to ask, what if the whole thing is just wrong? To kill the conjecture, all you need is one single even number that doesn't work. Just one. And people have looked. By hand, back in the 30s, they checked up to 100,000. Today, computers have checked up to 4 quintillion. That's a 4 with 18 zeros after it. And the number of counterexamples they found? 0. Not a single one. In fact, all the evidence we have screams that it's true. Look at this graph. They call it Goldbach's comet. It shows how many ways each even number can be made from 2 primes. And the trend is just undeniable. As the numbers get bigger, the options increase. For it to suddenly drop to 0 for some massive number out there seems almost impossible. So this all leads to one last big question. The Goldbach conjecture, as far as we know, has no practical use. It's not going to build a better phone or cure a disease. So why on earth would people like Chen Jingrun risk everything and dedicate their entire lives to it?
And maybe this quote says it best. The search for knowledge isn't always about a practical payoff. Sometimes it's just about passion. It's about pushing at the edges of what we know, just to see what's there. You just never know when solving a useless problem might unlock a whole new way of seeing the universe. So it makes you wonder, what's a problem you just can't stop thinking about?